So I gave you this compound inequality to solve. And it looks like everybody did some algebra, did some calculations that boiled each of these inequalities, 3y minus 4 is greater than 5, and 2y minus 3 greater than or equal to negative 9. Everybody did some algebra that boiled it down to numbers like 3 and negative 3. It seems like we all agree that 3 and negative 3 are a part of this answer somewhere. Okay, great. But then what we did with those numbers wasn't the same from person to person. And I think that it will soften the blow to say that I agree with none of the answers that are at the bottom of the screen. You all have a piece of it, but nobody has all of it. See, what's the old saying about somebody in a dark room with an elephant, like 3 people in a dark room with an elephant? One person is feeling the trunk and saying, oh, this feels like a snake. Another person is feeling the leg on the back, oh, this is a tree trunk, right? And then nobody has the complete perspective that it's an elephant in the room until you flip on the lights. So let's flip on the lights and figure out the sense in which everybody has a piece of the answer, but nobody has the whole answer here. So let's first of all go through what it was that you did in this problem. Where did this 3 and this negative 3 come from? Somebody, let's take the negative 3. Where did this negative 3 come from?
That's for the second operation.
Okay, so for the second inequality, 2y minus 3 is greater than or equal to negative 9. Walk me through the process of where that number negative 3 came from. Okay, so we added 3. Again, we're following the reverse order of operations to get that y by itself. So dealing with addition and subtraction first. 2y is greater than or equal to negative 9 plus 3, which is negative 6. And then, yep, now we can handle the division. And so, yeah, what I end up with here is I end up with a y on the left side, a negative 3 on the right side, and in between them I have a... Do I have to switch the sign, or can I leave the sign? When do we switch the sign? Thinking about what we talked about on Wednesday. Right, when you're dividing by a negative number, or multiplying by a negative number, then the sign needs to switch. But here we divided by 2, positive 2, so we can leave the sign the way that it is. So from that first inequality, which is the second inequality, I guess, on this page, but from that first piece, what I'm seeing that we got from that was the inequality y greater than or equal to negative 3. And in that respect, therefore, I'm kind of saying that, yeah, I like the negative 3 that we saw right here, and I like the y greater than negative 3 thing that we saw in this example, right, in this part of the answer. So that's one piece of our elephant. It comes as no surprise then that where does the positive 3 come from? The other inequality. Same deal. 3y minus 4 is greater than 5. So to get that y by itself, we would add 4 to both sides. That's going to give me the inequality 3y is greater than 9. And then dividing by 3 on both sides, I end up with a y on the left, 9 divided by 3, which is 3 on the right, and what inequality sign in between them? Greater than. Again, we don't have to flip the sign here because we divided by a positive 3 to get there. So, okay, that means that as far as the second answer here in the box is concerned, it's gotten pretty close to where we want to be for our final answer. In fact, I would argue that it is 80% of the way there. So I'm going to rewrite what we have up here at the top. Y greater than 3, y greater than or equal to negative 3. But here's where the issue comes in. There's one part of the problem that you have left undiscovered. It's this word that joins these two inequalities together, the word and. I notice very often in this class that at this stage in the game, a lot of students can get to this step, but then stop there. We're not done until we have a single answer to this problem. I want to know in as simplified a form as possible what values of y satisfy this compound inequality. Not that satisfy one of them or the other, but which satisfy both of them simultaneously. And in fact, that's what we mean by the word and, connecting these two inequalities. I want to find the y's find the y values, for which both of these two inequalities simultaneously hold. So, for which both are true. So we have more work to do. We have to stick our two answers together into a single answer by insisting that they both be right. And this is the step that's new to this part of our course. This is a skill that we haven't talked about together yet. And just like last time, I'm going to recommend that we start exploring this skill by drawing a picture. Sketching our two pieces on a number line to then hopefully figure out how those two pieces fit together into a single answer. So I'm going to put out some tick marks on my number line here. Do one more over here. So let's have -3, -2, -1, 0, 1, 2, 3. I suppose -4. All right, so here's a number line. And let's take each one of these two pieces and sketch that piece individually. So we'll have let's say a blue piece. Let's say y is greater than 3 is our blue piece. And then y greater than or equal to -3, let's make that an orange piece. So I want to sketch each one of these two, actually not orange, let's make it red. So a blue piece and a red piece. Starting with y greater than 3. What would that picture look like if I sketched it on this number line? We talked about this on Wednesday. How do we sketch y is greater than 3? Okay, so we start with an open circle. Where? So we start with an open circle at 3. Why open, by the way? Because y equals to 3 is not a part of the solution. So a greater than sign will turn into an open circle every time at this stage. Okay, so I have an open circle at 3, and then which part of the number line do I shade from there? Which direction? Yeah, I'm going to shade to the right of there. So just dial that back there. There we go. So that's the piece that corresponds to the blue inequality, y greater than 3. So there's that piece. For the other piece, for the red piece, y greater than or equal to -3, well, how do I start with that one? So what am I going to put at -3 for that inequality? A closed circle, and we want a closed circle this time because it's okay for y to equal -3, because -3 is included in this solution set because we have a greater than or equal to symbol. And which direction do I want to shade from that closed circle? Also to the right, because we're looking for y's that are greater than or equal to -3. So there's what the blue piece looks like. There's what the red piece looks like. My recommendation for any compound inequality problem that you ever do is to do this kind of sketch. Put these two pieces, one right on top of the other, on the same number line before you go any further. This is the last time we're going to consider those two things separately. We now need to combine them together somehow. We need to answer which numbers on this number line would not only be shaded blue, but would also be shaded red. Where do those two sets overlap? How can you describe them? Say again? So +3. Let's think about +3 for a second. So +3 belongs to which one of these two sets? The red one or the blue one? It belongs to the red one. So here's +3 right here on the number line, right? It belongs to the red set. What about the blue set? It's +3. So +3, Jordan, you were telling us before, +3 doesn't belong to the blue set because the blue set is only y greater than 3. So 3 doesn't belong to both. What's an example of a number which would belong to both? 3.1, for example. If I just take this little purple thing that I just drew in here and I just nudge it over to the right a little bit. 3.1 belongs to the red set because it's greater than 3. It also belongs to the blue set because it's greater than or equal to negative 3. So 3.1 has got to be a part of our solution. And in fact, any other number which is greater than 3 will also belong to both of those two sets. So what we're really doing when we are ANDing these two things together is we're looking for the overlap between these two sets. What numbers are in both the red set and in the blue set? And 3 is not included, but anything which is greater than 3 looks like it is included. So what is a simplified way to write our solution for this problem? If I wanted to write it, let's say, as an inequality, what can I say about the y's which belong to the purple set? What are they? Yeah, exactly. Those y's which belong to both sets are exactly those y's which are greater than 3. So you might even think about that as the next line in the simplification of our answer. When those two sets come together, what we get is a set consisting exactly of the numbers y which are greater than 3. Which looks like we only took one piece of this as part of our answer, and that is what happened here. In general, depending on how our two sets overlap, we might get one of the pieces by themselves, we might get something else entirely. And to finish this line of reasoning, let's also finish by expressing this answer in interval notation, as was asked for in the original problem and will probably be asked for when you see a question like this on an exam. How can I express this purple set using an interval? What is the least that this can be? What is the greatest that can possibly be? And how do we use notation to express that? Let's start with the least. What's the lowest endpoint of the purple set? It's 3. What's the highest endpoint of the purple set? How far to the right does it go? Infinity. So we'll put an infinity here. We'll put a comma in between. Now all we need to do is decide whether each of these gets a round bracket or a square bracket. Starting with infinity, what does that get? Round bracket. All the time, anytime there's an infinity, always a round bracket, because infinity is not a number, and therefore it can never be included in one of our answers. And then how about 3? What does 3 get on the left side? Why do we know it's also a round bracket? Yeah, because 3 is not included. So an open circle that came from having a strictly greater than sign translates into a round bracket in our interval notation.